everybody, and welcome back to another Ms. Pollard Math YouTube video. Today we're going to be going over volume, and as always, it's very important to know what does volume mean before we're going to apply it, before we're going to figure out how to solve for it. We are going to have to know what that means. So for a definition of volume, volume is a space inside of a 3D solid. So inside our 3D shapes, that is the volume that we're trying to calculate. Let's figure out what type of shapes we're going to be looking at in this video. So we're going to be looking at the volume of cylinders, of cones, of spheres, and hemispheres. And we're going to look at some word problems and combine those shapes with our composite solids. So there's a lot of good stuff in here. So let's see how we are going to complete these. So let's start off with the volume of a cylinder. So it's important to know what the volume of a cylinder formula is. We are going to have this memorized. So the volume of a cylinder is pi r squared h, where r is our radius and h is our height. So we're going to take all the information and plug it into our formula. My students, I tell them for pi to use 3.14 because for some reason when we use our calculators, it leaves it as pi. It's a little confusing. So I'm going to use 3.14. Your teacher might have you just use the pi button, but either way, we will get the same answer. So let's apply a practice problem to make sure we can see how to complete these. So we are given this problem. And as always, we are going to have to write down what formula we are working with. We've only seen one formula so far, so obviously that's the one we're going to use. So my volume equals pi r squared h. We see in our diagram we have two circular bases, and we have a portion of it being wrapped around. That creates a cylinder. We know this is a cylinder. So we are going to have to plug in the information given. So we have pi, which I'm going to have as 3.14. We have our radius squared. Well, what is a radius? If we don't know what a radius is, we can't continue here. So our circular base will have a radius. A radius goes from the middle of the circle outward. This could go up, this could go sideways, diagonal, anywhere from the center out to the outside of the circle is going to be the radius. So this diagram tells me the radius is 3. So I have pi times 3 squared, and my height is how much it's up and down, which is 6. So times 6. I'm going to put that in my calculator as 3.14 times. If I know 3 squared is 9, I can put times 9. However, what if it was like 3.2 times 3.2? I might not know that off the top of my head, so I just always do 3 times 3, because 3 squared is 3 times 3, times my height, which is 6. I put that in my calculator, and I get my volume. We have to put the approximation symbols. Because pi goes on forever, but also because I'm just using 3.14, I have to say approximate because it's not exactly 169.56, and I label that as miles cubed. Volume is always cubed. We have two variables here, r and r. We have the height here, that's 3, so we have to do miles cubed. So this is how we would apply volume to a cylinder. Let's try a problem where now we're going to be looking at cones. So our volume formula is 1/3 pi r squared h. So if we're able to memorize the cylinder volume formula as pi r squared h, we're just throwing a 1/3 in front of that. The reason that it's 1/3 is because if we have a cylinder, we can chop it into 3 portions and have a cone. So 1/3 of it, of our cylinder volume, is a cone. So that's the reasoning why, because sometimes we're like, why does that make sense? That's the reasoning why, but if you just want to memorize it's the volume of a cylinder multiplied by 1/3, then we are good to go. So let's look at a practice problem and how we would apply that 1/3 on the outside. So I have this cone here. We have to be observant that this is a cone. It has a point with a circular base. So we're going to plug in what we know. However, they're giving us from one side of the circle to the other side of the circle is 25. And if we think back to our geometry vocabulary words, that is our diameter. And we know that our diameter is double our radius. So our radius goes from the one side to the middle. Well, this is 2 times of that. So whenever you're giving the diameter, you have to divide that in 2. So you do 25, because that's my diameter, divided by 2, and I get my radius as 12.5. So I'm going to put 1/3 pi. Like I said, my radius is 12.5 squared. My height, it says up and down, is 18. So I'm going to multiply that by 18. So inside my calculator, I'm going to put for pi 3.14 times 12.5 times another 12.5 because it's squared times 18. And I press enter. So that would be if we were working with a cylinder. That's what that volume was. But we are multiplying by 1/3. And if we remember our rules, multiplying by 1/3 is the same thing as dividing by 3. So I'm going to take what I just did, this, times this, and divide it by 3 to get my volume of that cone. And when I do that, I get my volume as approximately 2,943.75 meters cubed. And that will be my final answer. So the only portion that was a little bit different here is that we're multiplying by that 1/3, and also they were giving us the diameter instead of the radius. So we take the diameter side to side, divide it by 2, and that's our radius. Let's take a look at a sphere and its formula. For the volume of a sphere, that formula is V equals 4/3 pi r cubed. As you can tell here, we don't have anything to do with the height. The height of a sphere does not affect its volume, so we're just going to work with the radius, which I think that's great. We only have one number that's given, and that has to be the number we're using unless it's the diameter. We have divided by 2, but still, we're just working with one number to make sure we have the radius. So for this problem, I have this sphere here, and I'm going to use the formula. We do have the radius because it's going from the center of the sphere over, so I'm going to do 4/3 pi, and then 9 cubed. So this is where we have to be a little careful when we're putting this in our calculator. We could do 4 divided by 3 times this times this. What I like to tell my students is, though, do the 4 times the pi times the 9 to the third first. So I do 4 times 3.14 times 9 to the third is 9 times 9 times 9. So I'm going to put that in my calculator. 9 times 9 times 9. And then I press enter. So I did 4 times my pi times my 9 times my 9 times my 9. I pressed enter. And then I have that 3 down here. So I'm going to divide by that 3. And then when I do that, I get my volume as approximately 3,052.08. And as always, I need my labels. So it's yards. So I'm going to put yards cubed. So once again, we are given our radius. The only little tricky part here is plugging it into the calculator. I have to do my numerator times pi times 9 cubed and divide that all by 3. Let's take a look at a hemisphere and see what we would do for that type of problem. So now we're going to be working with the volume of a hemisphere, and it's important to know what is a hemisphere. A hemisphere is half of a sphere. We think about it, the world is a sphere. We have the northern hemisphere, southern, western, eastern hemisphere, so that's half of our globe, like we learned in history class. So let's find the volume of a hemisphere. Well, like I just said, our hemisphere is half of a sphere. So we took our sphere formula, which was 4/3 pi r cubed, and divided that in half, because 4/3 divided by 2 is 4/6. If we simplify that fraction, that gives me 2/3. So we took our sphere formula, divided that in half, and got 2/3. Now let's apply that. So I am given this hemisphere. However, this time, once again, I'm given the diameter. So I have from one side to the other side is 23. Every time I'm given the diameter, I have to divide it in half. So I'll do 23 divided by 2, and I get 11.5. So I have 2/3 pi times 11.5 cubed. Like before, instead of putting the 4, though, we're going to put the 2. So I'm going to do 2 times 3.14 times 11.5 times 11.5 times 11.5. There's 3 of them, so it's to the third power, so I multiply them 3 times the pi times the 2. I click enter, and then I'm going to divide it by that 3 in the denominator. And I get my volume. Once again, need the approximation symbols because it's not exactly 3,183 points. I'm going to say 7. You could do 2 decimal places, but that's 0.698, so that would be 0.7 anyways. So we're going to put 0.7, and once again, this is in yards, so I have to put yards cubed. So these are all the different types of volume problems. We're going to go over the types of solids. We're going to be going over the cones, the cylinders, the spheres to hemispheres. Now we're going to apply all of that knowledge. So let's look at a composite solid to see how we would complete that problem. To begin this problem, we first have to understand, what does composite mean? Composite means resting on top of each other, within each other. So composite means more than one item on top of each other, within each other. So that's what we're going to be looking at. So we each time are going to find the volume of both of the shapes, and if they're within each other, we're going to subtract them. If they're on top of each other, we're going to add them. So let's look here. I can clear as day see that this portion is a cylinder. So I am going to do the cylinder formula. I always like to write down what I'm working with. So I'm working with a cylinder. I have to remember that cylinder formula. This is why it was important to memorize these equations. My cylinder formula is pi r squared h. So let's work with that first. I see in my cylinder a radius. It's going from the center over of 10. So I have pi times 10 squared. My height of my cylinder from here upward of it is 18. So we always look at the circular portion for the radius. For the height is from the bottom of the cylinder to the top, which is 18. And I'm going to put that in my calculator. 3.14 times 10 times 10 times the height, which is 18. And I get my volume as approximately 5,652 centimeters cubed. Now I have to determine what's that other shape. What's that shape over here? As we can see, it's a hemisphere. It's half of a sphere resting on top of the cylinder. So I'm going to use my hemisphere formula, which is 2/3 pi r cubed. So for this problem, all I need to determine is what's my radius. Well, if my radius of this cylinder is 10, it's the same thing for the cylinder, like the circular portion on top, which is 10. So my radius of this hemisphere is going to be 10. So I'm going to have 2/3 pi times 10 cubed. So I'm going to do 2 times 3.14 times 10 times 10 times 10. Press enter, and then divide that by 3. And I get my volume as approximately 2,093.3 repeated centimeters cubed. Now that I have both of my equations here, like I said, they're resting on top of each other. So we're going to add these two together. So I'm going to do 5,652 plus my 2,093.3. Add 5,652. And I get my volume as approximately 7,745.3 repeated centimeters cubed. And that is my final answer. So if we're able to find the volume of a cylinder and the volume of a hemisphere, all the extra step here is adding those two together. Let's look at a word problem and see how we would have worked with those. Now we have this word problem, and it looks a little bit lengthy, but we're going to underline the important parts to make sure that we're just focusing on what's going to be useful for this problem. So I have a container shaped like a cone to recycle aluminum cans. It has a height of 7 feet, I always need my height, and a diameter of 3.2 feet. The container is full, and we want to know how much the contents weigh. If the average weight of aluminum is 37 ounces per square foot, that's another number I think is going to be important. So what I am going to do here is, I see I'm working with a cone, so I'm going to use the cone volume formula, which is 1/3 pi r squared h. They tell me that my diameter is 3.2, so I am going to have to divide that in half. So I get my calculator, and I do 3.2 divided by 2, and my radius is 1.6. So I have 1/3 pi times 1.6 squared, and they say the height is 7. So times 7, and I put that in my calculator. 3.14 times 1.6 times 1.6 times 7 equals divided by 3, and I get my volume as approximately 18.76, and it's labeled in feet cubed. But they're not asking for what the volume is. They're asking for how many ounces are there going to be. What's the weight going to be? So I have to take my factor, which is my 37 ounces per square foot, and I'm going to multiply that. If I'm trying to convert from feet cubed to ounces, I have to multiply by 37. So I have my 18.76 times my 37, and I get approximately 693 they say to round to the nearest tenth, however, it's 0.98, so I'm just going to leave it like that, 9/8, and I'm going to label it as ounces because we are multiplying by the ounces. So that is the amount of ounces we would need. We first find the volume, and then we are going to multiply it by our factor to be able to determine how many ounces there are. Let's take a look at another problem and see what we would have to do for that one problem. Now we have a snowball, and the snowball has a diameter of 5.5 centimeters. We want to know how long it would take for the snowball to melt if it melts at a rate of 2.6 centimeters per minute. So as always, every single time we have a word problem or any type of problem, we are going to want to find the volume. So I'm going to use my volume formula. A snowball is a sphere. If you make a good snowball, they're definitely talking about the most beautiful snowball there is, so that's going to be a sphere. That formula is 4/3 pi r cubed. My diameter is 5.5. I have to divide that in half to get my radius, which is 2.75. So I have 4/3 pi times 2.75 cubed, and I'll put that in my calculator. 4 times 3.14 times 2.75 times 2.75 times 2.75. I press enter, and I get divided by that 3, and I get my volume as approximately 87.07, and I label it as centimeters cubed. Now with this problem though, we are working with something melting. When we're working with melting or inflating, and we're trying to find how much time is going to be division. So I'm going to divide it by our rate of 2.6. So I'm going to do divided by 2.6, and I get approximately 33 points, says 1 decimal place, so 5, and we label it in minutes. So like I said before, when we have volume problems, if we're trying to convert it from one measurement to another type, we're going to multiply. However, when we're talking about time and seeing how much time it will take for something to occur, we're going to use division. Let's take a look at another problem. Now we have something a little bit different, where we are given the volume, we're given the height, and we're trying to find the radius. So this is very important to determine what our steps are to be able to figure out the final answer. So we're working with the volume of a cone. The volume is 320, the height is 4, and we want to find the radius. So once again, we always need the volume formula that we are working with. The volume formula is of a cone, which is 1/3 pi r squared h. My volume is 320, so I'm going to set that equal to my volume formula. We know 1/3 and pi are staying there. Those are our numbers. R squared is something we're trying to find. My height is 4. So I can multiply this any way. I could do 4 times 3.14 divided by 3. I could do pi 3.14 times 4, then divided by 3. Doesn't matter which way we could go. We could go from left to right or right to left. Doesn't matter. So we do 3.14 times 4. I press enter. Then because of that 1/3, I divide by 3. And I'm going to put that number out front. So I get 320 equals 4.186 repeated r squared. Then once I do that, it's like we just have a plain variable. I know we'll get to that square in a second, but if I had 4.186 r, I would divide by that 4.186. So I'm going to divide that over. Repeated. And when I do that, I get my r squared is approximately 76.43. We saw a number being set equal to a square when we did our Pythagorean theorem. We had a squared, b squared, c squared, and we were trying to find our a, b, or c. When we got to this step here in that portion of our topic, we took the square root to get rid of. The opposite of squaring something is square rooting. They cancel out. Just like multiplication cancels out with division, squaring and square rooting cancel each other out. So in my calculator, I'm going to put the square root of that number, and I get my r. We're rounding to 1 decimal place. So my r is approximately 8.7 centimeters. I need to label that in centimeters. When we're working with radius, heights, any type of distance, that's feet and centimeters. When we're working with area, that's squared. When we're working with volume, that's cubed. Those are the set things we need to remember. So if I'm asking you for the radius, you have to give me that in centimeters. We also really need these approximation symbols because here we did 3.14, which is an approximation. We rounded here, we rounded here, we rounded here. So there's a lot of rounding going on that's making it not exact. So you must put your approximation symbols and the right type of labels for these problems. So this was a lot. We went over a lot of the topics for volume. We went over the volume of a sphere, hemisphere, cone, cylinder, but now you saw all the different types of problems and hopefully you are ready to tackle the volume topic.